Hello, this is Mrs. Ward, and I'm going to go over the 4.2 review worksheet for the quiz next class. So this is a very quick review worksheet, and it just wants to see if you know the properties to find the derivative without having to do the limit definition. So number one, to find the derivative of f of x is equal to x to the seventh, you are going to take your power, which is 7, times x, reduce your power by 1, which is 6. So your final derivative is just simply going to be 7x to the 6th. The second one, I have a constant, so you can think of that as times x to the 0, because that is 1. Most people don't do that. Whenever they're finding the derivative of a constant, they just know that it's 0. Because that should make sense. If I were the graph, f of x is equal to 9, I would have a horizontal line. If I have a horizontal line, the slope is always equal to 0. Number 3, when I go to do this, before I do it, I'm going to rewrite my function and rewrite that power instead of the 8th root. I'm going to think of that as x to the 1/8 power. Still following the power rule, I'm going to take 1/8 times x and then take 1/8 minus 1. So that would be 1/8 minus 8 over 8. So I'm going to have negative 7/8. I'm going to rewrite it because I don't want to leave it with a negative exponent. So the 1 is going to be in the numerator, the 8 is going to be in the denominator, and that x to the 7/8 will also be in the denominator. Okay, number 4, given the function 9x to the 11th, again, to find the derivative, I'm going to take the power, which is 11, times that 9x, reduce the power by 1, so that will be 10. So my final derivative is going to be 99x to the 10th. Number 5, I'm going to rewrite before I find that derivative. So I am going to rewrite the function as 8 times x to the negative 9th. Now I'm going to do that power rule. And I'm going to take negative 9 times 8x, reduce this power by 1, so that'll be negative 10. When I multiply 9 times 8, I get negative 72x to the negative 10th. So then my final derivative, that negative 72 is negative, but it's still raised to a positive power, and then x to the 10th. And that is my final answer. Number 6. I am going to find the derivative, and I'm going to go term by term. So I'm going to do 4 times 8x to the 3rd minus 3 times 6x squared plus 1 times x to the 0 minus 0. I don't know if I'd do all that writing. I think I would have just skipped to 3rd to x cubed minus 18x squared plus 1. Okay, number 7, it's asking find the time when the position of the function is at 0. So in place of s of 0, I want to put a 0 in there. So I'm going to have 0 is equal to negative 16t squared plus 48t plus 160. I'm going to divide everything by negative 16. Because everything is divisible by negative 16. And when I do that, I'm going to get 0 is equal to t squared minus 3t minus 10. So my product is negative 10. My sum is negative 3. So I'm going to end up using negative 5 and 2. So that factors as, I'm going over here. So that factors as t minus 5 times t plus 2. And that's still equal to 0, so t is going to equal 5, t is going to equal negative 2. Well, the negative time doesn't make sense, so my final answer is going to be 5 seconds. That's how long it takes for it to hit the ground. Number 8, it says find the average velocity. So to find the average velocity, I'm going to s of 0, which is my initial height. I substitute 0 into this and I'm going to get 160. So my one order pair is 0, 160. Then I'm going to do the s of 5, which I just did. I found that to be my 0. So my other order pair is 5, 0. I want the average, which means I want the slope of the secant line. So difference of the y. So 160 minus 0 over 0 minus 5. So I'm going to have 160 over negative 5. And that'll end up being negative 32 feet per second. and then find the instantaneous, which means derivative. So I am going to take the derivative of this function, so negative 32t plus 48, and I want to find the instantaneous derivative at 5, so that's when I'm hitting the water. So times 5 plus 48. And when I do all that, I get a negative 112 feet per second. And that's how fast I'm going when I hit the ground. Write a function that would have the following derivative. So there are multiple of correct answers for this. So what I'm going to do is the original function, to get here, I had to take, this power used to be 6, it used to be one more. So I am going to have to take that 8 and divide it by 6 and have x to the 6. Because if I were to take the derivative of that going backwards, I would take, I'm going to go over here, I would take 6 times 8, 6, and the 6's would simplify and then have x 8 to the 5th. So that's the way I'm thinking of it. So this original power was 2, so I'm going to have plus 3 halves x squared. And then the 2 had to be like x to the first, so plus 2x, and then any constant, doesn't matter, I'll say 43, I don't know. So one example is, that's going to be one example. This part is going to be the same for everybody. This is what's going to change. So know that there are multiple answers for that. All right, I hope this helps, and I will see you next time.